Hello, welcome to Guidance Education channel. We are continuing class 11 chemistry chapter 2 structure of atom. We will see the topic that is discussed developments that led to quantum mechanical model of atom. Under that we will be discussing Louis de Broglie concept of dual nature of matter and its significance. This topic also is very important. Questions are asked from this portion. Do not skip the video, watch the video completely so that you get all points cleared. And if you think the video is useful, do like the video, share the video, and if you have any doubts, leave your doubts or comments in the comment box below. If you have not subscribed my channel, do subscribe it now and also press the bell button so that you get intimated as soon as new videos are posted. Thank you very much. Your comments are of great significance. I take it as feedback of this video. Okay, thank you. Now let us start the class. In this video, we will discuss developments that led to quantum or wave mechanical model of atom. Two developments that took place at that time, quantum or wave mechanical model of atom. Let us see what they are. First one is Louis de Broglie concept of dual nature of matter. And the second one was Heisenberg uncertainty principle. We will first discuss the concept of dual nature of matter. Einstein in 1905 had already proposed the concept of dual nature of light. That is, light, which is electromagnetic wave, has particle-like nature and wave-like nature. To be more clear, energy is transported in the form of energy particles called photons. It has momentum just like any other matter. In other words, photons, which are particles, have wave-like property. So based on this, Louis de Broglie extended this concept to all type of matter, whether microscopic or macroscopic. So in 1924, he proposed the concept of dual nature of matter. What is the meaning? If electromagnetic waves have particle nature, then matter also has wave-like nature. That is, they have wavelength. The wave property of matter is called matter wave. Let me clarify further. Microscopic objects like electrons, protons, atoms, etc. And macroscopic objects like a piece of chalk, a metal ball, or a piece of stone, or say for example a car. When they are in motion, their path is wave-like. This concept will be very hard to digest because when we travel in a vehicle, say for example the car itself, we don't experience wave-like motion. Similarly, when a metal ball or a piece of chalk or a piece of stone is dropped, we don't see it moving down in the form of a wave. It is very hard to imagine that they are moving in wave-like path. But according to de Broglie concept, they are moving in wave-like fashion. Drawing an analogy with photons, he also gave an expression for wavelength of these matter waves. It is called de Broglie equation and de Broglie wavelength. Wavelength is represented as lambda. Now we will see his derivation of the equation. According to Planck's quantum theory, energy of a photon is equal to h nu. Nu is the frequency of the wave and h is Planck's constant. According to Einstein, energy of a particle having mass equal to m and velocity c is equal to mc square. The left hand side of the equation is same, right hand side is different, so the right hand side can be equated. So h nu is equal to mc square. Recall the relation of frequency with wavelength and speed. Frequency nu is equal to speed c divided by wavelength lambda. Substituting for frequency, this equation becomes equal to hc by lambda is equal to mc square. On the left hand side there is c and on the right hand side there is c into c. Therefore, One c on either side of the equation gets cancelled. Equal to h by lambda is equal to mc. From this, wavelength lambda is equal to h by mc. This equation is called de Broglie equation, and wavelength is called de Broglie wavelength. From this equation, it is clear that wavelength of matter waves is inversely proportional to mass. That means when mass increases, wavelength decreases. It cannot be detected. So that is why for macroscopic objects like piece of chalk, a metal ball, or a car, the wave-like motion cannot be detected. The wavelength is so small that it appears that the object is moving in straight line and not in wave pattern. For microscopic objects like electron, proton, atom, etc., the mass is so small that the wave nature can be easily understood. In this equation, C is velocity. So mc is equal to m into v. Mass into velocity is equal to momentum rho, which is represented as p. So this equation becomes de Broglie wavelength is equal to h by rho. So de Broglie wavelength or matter waves have significance only with reference to microscopic objects. So we will see the significance of de Broglie equation. For the purpose of that, we will discuss two problems. Let us see the first problem. A ball of mass 0.1 kilogram moves with a speed of 60 meter per second. Calculate its wavelength. So it is matter wave. We have to calculate wavelength. It is a macroscopic body. We will use de Broglie equation. Wavelength is equal to h by mass into velocity. Momentum is not given. We will substitute the quantities. 6.626 into 10 raised to minus 34 kilogram meter square per second. This is equivalent to joule second divided by what is the mass? 0.1 kilogram into velocity is 60 meter per second. So the units get cancelled. Only meter remains in the numerator. So this becomes equal to 6.626 into 10 raised to minus 34 meter divided by zero point 0.1 into 60 becomes 6, which on simplification becomes 1.104 into 10 raised to minus 34 meter. That is, wavelength is approximately equal to 10 raised to minus 34 meter. This is a very small length. Actually, this wavelength cannot be detected. That is, when this ball is moving, the wave pattern of its motion cannot be detected. It appears to be moving in straight line because its wavelength is very small. So we can conclude that de Broglie equation has no significance with reference to macroscopic objects or bodies in motion. So we have finished the first problem. Let us see the second problem. An electron of rest mass equal to 9.11 into 10 raised to minus 31 kilogram moves with a speed of 60 meter per second. Calculate its wavelength. This is also matter wave. We have to calculate the wavelength lambda. It is a microscopic object. In the case of the ball, the mass is 0.1 kilogram. Here, the mass of the electron is very small. 9.11 into 10 raised to minus 31 can be taken approximately as equal to 10 raised to minus 30 kilogram. Mass can be taken like that. Okay, again we use the same formula. Lambda is equal to h by mv, and substituting we get 6.626 into 10 raised to minus 34 kilogram meter square per second divided by 10 raised to minus 30 kilogram into 60 meter per second. Here also the units can be cancelled, and then what remains is 6.626 into 10 raised to minus 34 meter. On simplification, This 10 raised to minus 30 and this 10 raised to minus 34 becomes 10 raised to minus 4. 6.626 into 10 raised to minus 4 by 6 into 10 raised to 1. And simplification, that will be equal to 1.104 into 10 raised to minus 5 meter. This becomes approximately equal to 10 raised to minus 5 meter. Here is 1 meter. This is for electron, which is microscopic. Both the ball and the electron are traveling in the same speed, but the wavelength of the electron is much greater than the wavelength of the ball. This is because the mass of the microscopic body, electron, is much smaller than the mass of the macroscopic body, namely the ball. The wavelength of the electron can be detected. That is, when the electron is in motion, it is moving in wave pattern that can be detected, unlike the macroscopic body whose wavelength cannot be detected. So, de Broglie equation is significant only for microscopic bodies or objects. By the way, 10 raised to minus 5 meter can also be written as 10 raised to 3 angstrom. If you have any doubt, you may post it in the comment box below. If the video was useful, do like the video, share the video, and also leave your comments in the comment box below. Your feedbacks are very much appreciated. If you have not yet subscribed my channel, do subscribe it now and also press the bell button for notification of new videos. Thank you very much. We will meet in the next video with Heisenberg's uncertainty principle before we pass on to quantum mechanical model of the atom. Okay, bye.